Hi everyone, my name is Burak and I am an undergraduate physics student in Bilkent University. And today I would like to present you our Physics 212 Modern Physics project. In this project we aim to develop an STM microscope. So what is an STM microscope? STM microscope is a type of microscope that we do not require any optical setup, and just using a quantum tunneling we can get really atomic level and detailed images of the sample. So the basic setup is something like that. We initially have a sample and a tip. We created voltage difference between the sample and the tip so that electrons can travel. We decrease the distance between the sample and the tip so much that it is less than 1 nanometer. At this point, because of the pressure on the electrons, some of the electrons tunneling from sample to the tip, and that creates a really small current. It's about 1 nanoampere. And by measuring this, by measuring and evaluating the results of the current, we get really detailed images in atomic level of the samples. So how it works? There are actually 3 different components of the setup in order to work. So evaluate them one by one. The first component of the setup helps us isolate all the oscillations. Since the STM microscope requires a really precise measurements in order to get uninterrupted data, we use eddy current setup. In this setup, we have a magnesium plate at the very bottom, and there's iodine magnets that we will interact each other. From these interactions, we can be able to eliminate all the oscillations. Then there's electronics part. I can say have 4 different electronics actually. First, we have a preamplifier. We get the current from the tip, which I mentioned really small, and we amplify it. And then the amplified current goes to the motherboard, where we have a DC and DAC components. Here we transfer the current data to the microcontroller, and also from there we give voltage to the sample, and also we control the piezo driver. The piezo driver helps us to move the tip in order to evaluate the data of a small portion of the sample. And at the end we have the microcontroller, which we get and calculate all the data. At the end we have the computer calculation and the coding part. Here we get the data from the microcontroller to the computer, and at the computer we analyze and evaluate this data by using proper C+ and the Python codes. By using these codes, we are able to get some really detailed atomic pictures of the corresponding samples. Unfortunately, at the end we couldn't get any image data. That is because we occurred issue with the preamplifier phase. We think that is because of the op-amp that we chose. Unfortunately, we couldn't get it done. Thank you for your time, and thank you for listening.